Before we begin, take a slow, comfortable breath. And if you enjoy drifting through calm space stories like this one, you're gently invited to subscribe, so these quiet journeys can always be here whenever you need them. Tonight, we're not rushing anywhere. There's no destination to reach, no answers you need to remember. Instead, we're simply going to float and wonder about something that has followed every human being who has ever lived. Time. It's the soft ticking behind our thoughts, the invisible current that carries memories forward, and the quiet reason why moments appear and then fade away. For centuries, people have asked the same question in different ways. Can time be bent? Can it slow down, stop, or even move backward? In the universe above us, where stars drift for billions of years, and light travels across unimaginable distances, time does not always behave the way we expect. So tonight, as your body settles and your breathing grows steady, we'll gently explore what modern science tells us about time, not with equations or urgency, but as a calm story written into the fabric of the cosmos. There's nothing you need to do, nothing you need to solve. Just listen and let the universe carry you forward, one quiet moment at a time. Chapter 1. The human idea of time. Time is something we live inside long before we ever learn its name. As children, we feel it without measuring it. A day feels endless. A summer feels like a lifetime. Moments stretch wide, as if the world has all the patience in existence. Later, as we grow, time begins to change its character. Days become shorter, years pass more quickly, and eventually, many of us find ourselves wondering where all that time went. But before clocks, before calendars, before seconds and hours, time existed for humans as a feeling, a rhythm woven into breath, light, hunger, and rest. The rising of the sun was time. The lengthening of shadows was time. The slow return of the stars each night was time. Early humans did not count minutes. They listened, they watched, they remembered. Time was not something you chased. It was something you moved with. Even today, much of how we experience time has little to do with clocks. Think of a moment when you were waiting, perhaps for news or for someone to arrive. Each minute felt heavy, stretched thin, almost reluctant to pass. Now think of a moment when you were deeply absorbed, reading, dreaming, creating, or simply being at peace. Hours disappeared without leaving a trace. The clock moved the same way in both moments, but time, as you experienced it, did not. This is the first quiet clue that time, at least for humans, is not just a physical thing. It is also a mental one. Our brains do not measure time directly. They reconstruct it. We piece together time from change, from movement, memory, and expectation. Without change, time becomes strangely difficult to sense. This is why moments of stillness can feel timeless, why deep sleep contains no duration, why a single memory can feel closer than something that happened yesterday. Memory plays a powerful role here. The past exists for us only because we remember it. The future exists only because we imagine it. And the present. The present is a thin, fleeting boundary between the two. Neuroscientists often describe the present moment as lasting only a few seconds at most. Everything beyond that is already memory or anticipation. So even as you listen now, the words you just heard belong to the past, and the words you expect belong to the future. The present is always slipping through our fingers, quietly and continuously, yet we treat time as if it was solid, as if it were a straight line, divided neatly into equal segments. This idea feels natural because it's useful. Clocks help us coordinate, calendars help us plan, schedules help societies function. But usefulness does not always mean truth. For most of human history, time was cyclical, not linear. Days followed nights. Seasons followed seasons. Birth followed death. And life returned again through new generations. There was no universal starting point, no ultimate ending. Time was a wheel, not an arrow. The idea of time as a straight line, with a past behind us and a future ahead, is relatively recent. It emerged alongside written history, mechanical clocks, and eventually modern physics. Once time could be measured precisely, it could be treated like distance. Minutes became units. Hours became quantities. Time could be saved, wasted, spent, or lost. We began to speak of time as if it were money, or space, or fuel. But deep down, our minds never fully adapted to this idea. Emotion still stretches time. Attention still compresses it. Fear slows it down. Joy makes it vanish. This is not a flaw in perception. It's a feature of being human. Our sense of time evolved not to be accurate, but to be meaningful. Time helps us survive. It tells us when to act, when to rest, when to remember danger, and when to let go. From this human perspective, time feels like something that flows. We say it passes. We say it moves forward. We imagine ourselves traveling through it, from past to future, one moment at a time. This flowing image is so intuitive that it feels almost impossible to question. And yet, physics will eventually ask us to. But for now, we stay with the human view. Because even in modern science, this experience of time raises deep questions. Why does time seem to have a direction? Why do we remember the past, but not the future? Why does broken glass scatter, but never reassemble itself? These questions begin not in equations, but in everyday experience. You remember being younger. You do not remember being older. You can imagine tomorrow. You cannot recall it. Something about time appears asymmetric, uneven, biased toward one direction. This direction is often called the arrow of time, and long before science named it, humans felt it. We age, we decay, we move from possibility to memory. The arrow of time is deeply personal. It is written into our bodies, our stories, and our sense of identity. Who you are is shaped by what has already happened, not by what will. This makes time feel irreversible, like a river that never flows backward. And yet, the universe itself does not obviously care about this arrow. At the level of fundamental physics, many laws work just as well forward as backward. A planet can orbit in reverse. A pendulum can swing either way. Equations do not prefer yesterday over tomorrow. So where does our sense of direction come from? That question will carry us forward into the next part of our journey. But before we go there, it's important to pause and notice something subtle. Our idea of time is deeply tied to change. If nothing changed, no motion, no thought, no sensation, time would lose its meaning entirely. Imagine a universe frozen in perfect stillness. No stars forming, no particles moving, no minds observing. In such a universe, time would have no way to announce itself. Time, as we know it, requires events, and events require differences. This means that time is not just something the universe contains. It is something the universe does, and perhaps something we do with it. As you rest here, listening, notice how your own sense of time has softened. There's no rush, no urgency. Seconds no longer matter, only flow. This gentle shifting of perception is a reminder that time is not a single experience. It has layers. There is clock time, precise, mechanical, indifferent, and there is lived time, elastic, emotional, deeply human. Both are real, but they are not the same. In the chapters ahead, we will slowly move from this human sense of time into the universe's perspective. We will see how motion stretches time, how gravity bends it, and how extreme environments challenge everything we think we know. But we begin here, with the quiet truth that time, before it is a scientific concept, is a human story. A story told through memory, through change, through the gentle awareness of passing moments. For now, let that story settle. There is nowhere else you need to be. Time is already carrying you forward, softly, naturally, one calm moment at a time. Chapter 2. Why Time Moves Forward. There is a quiet mystery at the heart of time. No matter where you are, no matter who you are, time always seems to move in one direction, forward. You can remember yesterday, but you cannot remember tomorrow. You can watch smoke rise and disperse, but you never see it gather itself back into a flame. You can see a glass fall and shatter, but never see the pieces calmly lift themselves and return to the table. This one-way flow feels so natural that we rarely stop to question it. And yet, when scientists look closely at the laws of physics, they discover something surprising. Most of these laws do not care which way time flows. If you filmed two planets orbiting each other and then played the film backward, the motion would still obey the same equations. Nothing in the math would say, "This is wrong." At the deepest level, the universe seems almost indifferent to past and future. So why does time feel so directional to us? Why does it feel like an arrow, always pointing forward? To understand this, we need to gently introduce a concept called entropy. Entropy is a word that often sounds more intimidating than it is. At its core, it simply describes how things tend to move, from order toward disorder. Imagine a brand new deck of cards. Every suit is neatly arranged. Every number is in place. This is a state of low entropy, highly ordered, very specific. Now shuffle the deck. The cards scatter into a random arrangement. There are countless possible ways they can land. This is a state of higher entropy. If you shuffle again and again, the deck will almost never return to its original, perfect order. Not because it's impossible, but because it's unimaginably unlikely. Entropy is not about chaos for its own sake. It is about probability. There are far more ways for things to be disordered than ordered, and the universe, over time, tends to move toward what is most probable. This tendency is known as the second law of thermodynamics. It tells us that in an isolated system, one not receiving outside energy, entropy tends to increase, slowly, relentlessly, quietly. This increase in entropy is what gives time its direction. It's why eggs scramble but do not unscramble, why heat flows from hot to cold, why stars burn their fuel and eventually fade. The arrow of time, as we experience it, is closely tied to this gradual rise in entropy. But here's the part that often feels strange. Entropy does not force time to move forward. It simply makes forward motion overwhelmingly more likely. The laws of physics allow for reversals. They just make them so improbable that we never see them. To the universe, this difference matters very little. To us, it matters immensely, because we are made of processes that depend on entropy increasing. Our bodies function because energy flows. Our brains create memories because states change. Life itself exists far from equilibrium, constantly resisting disorder, but always producing more of it in the process. Every thought you have, every breath you take, creates a tiny increase in entropy. Time feels like it moves forward, because you are moving forward with it. Memory is a key part of this experience. You remember the past, because the past left physical traces, changes in your brain, records in the world. The future has left no such traces yet, so your mind experiences a direction from what is recorded toward what is unknown. This is why time's arrow feels psychological as well as physical, and yet it begins much deeper than the mind. It begins with the universe itself. Shortly after the Big Bang, the universe was in an incredibly low entropy state. Matter was distributed with remarkable uniformity. Energy was smooth and dense. This initial order is one of the great mysteries of cosmology, because from that starting point, entropy could only increase. Stars formed, galaxies emerged, structures grew complex, and over billions of years, entropy rose. The universe did not begin chaotic, it became chaotic, and this slow unfolding is what gives cosmic time its direction. Without that low entropy beginning, there would be no arrow of time at all, just change without direction. This means that the arrow of time is not something built into space itself. It is something inherited from the universe's origin. Time moves forward because the universe started in a very special state. As you let that idea settle, notice how gentle this explanation is. There is no cosmic engine pushing time ahead, no force dragging moments forward. There is only probability quietly unfolding, from simplicity toward complexity, from order toward disorder. And yet, within this unfolding, something remarkable happens. Local pockets of order can form. Stars organize matter into shining spheres. Planets gather around them. Chemistry builds complexity. Life emerges. These pockets of order exist only because they increase entropy elsewhere. A star shines by turning nuclear order into radiant disorder. Life persists by exporting entropy to its surroundings. Even as the universe moves toward disorder overall, it briefly allows islands of structure. You are one of those islands. Your experience of time, your memories, your sense of flow exists because of this delicate balance, because energy flows through you, because entropy rises around you. This also explains something subtle. Time does not feel the same everywhere. In moments of danger, your brain speeds up, recording more detail. Time feels slow. In moments of calm, attention softens. Time feels fast. This doesn't change the arrow of time, but it changes how you ride along it. Physics gives time its direction. Consciousness gives it texture. As we move deeper into the universe's story, this distinction becomes important, because while entropy explains why time moves forward, it does not explain everything about time. It does not tell us why time can stretch or compress, why clocks tick differently, depending on speed or gravity. Those ideas belong to relativity, and we will arrive there gently, soon. For now, it's enough to rest with this understanding. Time moves forward, because disorder is more likely than order, because the universe began simply and has been unfolding ever since, because memory records what has happened, not what has yet to occur, and because life itself is a dance along this arrow. As you listen, you may notice that your own sense of time has softened again. The arrow still points forward, but there is no rush. Entropy does its work patiently. The universe takes its time, and so can you. In the next chapter, we'll meet the ideas that challenged everything humans once believed about time. Ideas that revealed time not as a steady river, but as something flexible, stretchable, and deeply connected to motion itself. But for now, let this moment remain simple. Time is flowing forward, quietly, and you are flowing with it at exactly the pace you need. Chapter 3: Einstein and the Flexibility of Time. For most of human history, time was assumed to be steady, a universal background rhythm, a silent metronome ticking the same way, for everyone, everywhere. No matter where you stood in the universe, time was believed to flow at the same pace. 1 second here was 1 second anywhere else. This idea felt obvious, it felt comforting, and for everyday life, it worked well enough. But at the beginning of the 20th century, this quiet assumption began to unravel, not with noise or spectacle, but with careful thought. Albert Einstein did not begin by trying to break time. He began by asking a gentle question: what does it really mean for two events to happen at the same time? Imagine 2 lightning strikes. One hits the front of a train, the other hits the back. To someone standing on the platform, both strikes appear simultaneous. But to someone riding the train, moving forward at high speed, the front strike is seen first, and the back strike later. Which observer is correct? For centuries, the answer would have been simple. One of them must be mistaken. But Einstein realized something extraordinary. Both observers are correct, within their own frame of reference. There is no universal now that everyone shares. Simultaneity depends on motion. This realization shattered the old picture of time. Time was no longer absolute. It was relative. Relative to motion, relative to the observer, relative to how you move through space. This idea became the foundation of Einstein's theory of special relativity, and from it emerged one of the most surprising truths in science. Time can stretch. Time can slow down. Time is flexible. This is not a metaphor. It is not an illusion. It is a physical effect. When you move through space, you also move through time. But the faster you move through space, the slower you move through time. At everyday speeds, this effect is so small that we never notice it. But as you approach the speed of light, it becomes dramatic. A clock on a fast-moving spacecraft ticks more slowly than a clock at rest. This phenomenon is called time dilation, and it has been measured again and again. Atomic clocks flown on airplanes return slightly behind those left on the ground. Satellites orbiting Earth must constantly correct for time differences, or GPS would fail. Time is not the same everywhere. It depends on how fast you are moving. This challenges a deep intuition. We tend to imagine time as something that happens to us. But in relativity, time is something we move through. Just as motion through space can vary, motion through time can vary too. There is a limit to this motion. Nothing with mass can reach the speed of light. Light itself moves at a constant speed. For all observers, no matter how they move, this constancy of light is what forces time and space to adjust. To keep the speed of light the same, the universe bends time. It stretches seconds. It compresses distances. Space and time are no longer separate things. They form a single fabric, space-time. In space-time, Events are located not just in space, but in time as well. Your life traces a path through this fabric, called a world line. Most of the time, your path moves slowly through space, and quickly through time, but change the balance, and time responds. This means that two people, starting together and later reuniting, may have aged differently. This idea is often illustrated with the twin paradox. One twin stays on Earth, the other travels into space at near light speed, and then returns. When they meet again, the traveling twin is younger, not because of illusion, not because of malfunctioning clocks, but because less time passed along their path through space-time. The universe allows this, and yet there is no paradox at all. The paths were different. Time did not betray consistency. It simply followed geometry. This realization transforms our understanding of time travel. Traveling into the future is not science fiction. It is already part of physics. If you move fast enough or stay near intense gravity, you can experience less time than those far away. You move into the future of others by aging more slowly. You cannot return to their past, but you can arrive in a future that advanced faster than you did. This is one of the quiet truths Einstein revealed. Time is not a universal river flowing at a fixed rate. It is a landscape, and motion changes how you cross it. This flexibility does not feel natural because our everyday experience lies far from extreme conditions. We move slowly compared to light. Gravity around us is gentle. Time differences are tiny, but the universe does not share our comfort zone. Out there, particles race at near-light speeds. Stars orbit massive centers. Galaxies collide. In these places, time stretches and compresses as easily as fabric in motion. This also means there is no single universal present, no cosmic now. What is happening right now depends on how you move and where you are. This idea is deeply unsettling to human intuition. We want the universe to share a single moment, but relativity gently refuses. Instead, it offers something quieter. Each observer carries their own time. Each path through space-time has its own rhythm. There is no master clock, only countless local clocks, each ticking faithfully along its own journey. As you let this idea settle, notice how it softens urgency. If time itself is flexible, then rushing loses its meaning. The universe does not demand a single pace. It allows variation. It allows difference. It allows rest. Einstein once said that the distinction between past, present, and future is only a stubborn illusion. He did not mean that time is unreal. He meant that time is not divided the way we imagine. In space-time, all events exist as part of the structure. What feels like flow may be how consciousness moves along its path. This does not diminish experience. It deepens it. Moments still matter. Memories still form. Change still unfolds. But beneath it all, time is not pushing us forward. We are moving through it. This shift in perspective will soon take us further, because Einstein did not stop with motion. He went on to show that gravity itself bends time, that massive objects, slow clocks, that near black holes, time almost comes to a standstill. But those ideas belong to the next chapter. For now, rest with this gentle truth. Time is not rigid. It is not absolute. It stretches, it responds, it adapts, and as you listen, your own sense of time may be doing the same. There is nowhere you need to arrive, no moment you need to chase. You are already moving, exactly as the universe allows, quietly, naturally, through the flexible fabric of time. Chapter 4. Moving fast, aging slowly. When Einstein revealed that motion could stretch time, the idea felt strange but distant. It belonged to thought experiments, to trains of light, to clocks on spacecraft. But there is another way time can slow down, one that does not require great speed. It requires weight, mass, gravity. To understand this, we need to let go of an old picture. For a long time, gravity was imagined as an invisible force pulling objects together, a kind of cosmic tug. But Einstein offered a quieter, deeper explanation. Mass does not simply pull on space, it reshapes it. And when space is reshaped, time is reshaped as well. In Einstein's view, space and time are woven together into a single fabric. Space-time and massive objects, planets, stars, black holes, press into this fabric. They create curves. If you could see space-time, Earth would appear as a shallow dip. The sun would be a deeper one. A black hole would form a steep, almost endless well. Objects move the way they do, not because they are pulled, but because they follow the curved paths of space-time, and time itself flows differently, at different depths of this curve. The deeper you are in a gravitational well, the slower time passes. This effect is called gravitational time dilation. It is not speculation. It has been measured. Clocks on Earth's surface tick more slowly than clocks on satellites orbiting above. Clocks at sea level tick more slowly than clocks on mountaintops. The difference is tiny, but real. Without correcting for it, GPS systems would drift by kilometers each day. The technology guiding you through streets depends on Einstein's gravity, adjusting time itself. This tells us something remarkable. Time does not flow at the same rate everywhere in the universe. Even if you are standing still, even if you are resting, gravity quietly shapes your experience of time. This effect becomes dramatic near extreme objects. Imagine a clock far from any massive body. It ticks freely, unburdened. Now imagine another clock near a neutron star. The gravity there is immense. Time for that clock slows significantly compared to the distant one. If you could watch both clocks at once, you would see them drift apart, not because either is broken, not because either is wrong, but because time itself flows differently in different gravitational environments. Near a black hole, this difference becomes extreme. From far away, an object falling toward a black hole appears to slow down. Its clock ticks more and more slowly. Its signals stretch and redden. It never quite seems to cross the event horizon. Time, from the outside perspective, nearly freezes. But for the falling object itself, time continues normally, at least at first. This duality is one of the strangest aspects of gravity and time. Both perspectives are valid. Both are real. There is no single, absolute timeline that everyone shares. This realization has profound implications. It means that time travel into the future is not just about speed. It is also about gravity. If you spent time near a massive object and then returned to Earth, you could arrive in Earth's future. Others would have aged more than you. You would have moved forward in time, relative to them. This is not fantasy. It is physics. However, the universe sets practical limits. Neutron stars and black holes are not safe destinations. Their gravity is lethal, and the energy required to create artificial gravity of that strength is beyond any foreseeable technology. So while gravitational time dilation is real, it is not a tool we can easily use. Still, its existence changes how we think about time. Time is no longer a universal background. It is part of the structure of reality, shaped by mass, responsive to geometry. This brings us to a deeper insight. Gravity is not just a force. It is a consequence of curved space-time. And time is not just a dimension. It is affected by curvature. This means that extreme gravity does not just slow time. It changes what before and after even mean. Near black holes, the future and the center can become intertwined. Paths through space-time tilt. What was once optional becomes inevitable. This is why black holes feel so unsettling. They are not just places where matter disappears. They are places where time itself loses its familiar meaning. Yet even here, the universe remains consistent. There is no breaking of laws, no chaos, only geometry taken to its extreme. As you rest with these ideas, notice how quiet they are. Gravity does not announce itself loudly. It works patiently. Time does not shatter suddenly. It bends, even in the most violent places. In the cosmos, these changes happen according to gentle rules. This perspective invites a different way of thinking about time travel, not as jumping through portals, but as following paths through a curved landscape. You do not leave time, you move differently within it. This also explains why traveling backward in time is so much harder than forward. Gravity and motion can slow time, they can stretch it, they can create differences between observers. But reversing time would require reversing entropy, reversing causal structure, and reshaping space-time in ways that may not be possible. The universe seems willing to let time bend. It resists letting it break. As you listen, your own body remains deep in Earth's gentle gravity. Time flows for you, slightly slower than it does for satellites above. But the difference is small, comfortably small. You are not falling toward a black hole. You are resting, and in rest, time feels softer. This is not an illusion. It is a reflection of how deeply perception and physics intertwine. Gravity shapes time. Attention shapes experience. Both work quietly. In the next chapter, we will move closer to the most extreme environments in the universe, places where gravity is so intense that time nearly stops, places where our understanding is pushed to its limits. But for now, let this thought settle. Time slows near weight, near mass, near presence, and as you lie still, supported by Earth, you are held in space-time's gentle curve. Time flows, not fast, not slow, just enough, exactly as the universe allows. Chapter 5. Black Holes and Frozen Moments. There are places in the universe where time slows almost to a stop. Not metaphorically, not in imagination, but in the precise language of physics. These places are black holes. For a long time, black holes lived only in theory. They were solutions to equations, mathematical curiosities that seemed too extreme to exist in nature. But the universe, as it often does, proved willing to go further than human intuition. Black holes are now known to be real. They form when massive stars exhaust their fuel and collapse under their own gravity. As the core contracts, gravity grows stronger, compressing matter into an incredibly dense region. Eventually, a boundary forms, a surface not of matter, but of space-time. This boundary is called the event horizon. Cross it, and there is no return. Not because of violence, but because of geometry. Inside the event horizon, all possible paths through space-time lead inward. Even light, the fastest thing in the universe, cannot escape. But long before anything crosses that boundary, time begins to behave in unfamiliar ways. From the perspective of a distant observer, an object falling toward a black hole appears to slow down. Its clock ticks more and more slowly. Signals it sends out grow weaker and redder. The object never quite seems to reach the horizon. It fades. Time, from the outside view, nearly freezes. This effect is not a trick of vision. It is a consequence of extreme gravitational time dilation. The deeper the gravitational well, the slower time flows. At the event horizon, time slows so dramatically that the future of the falling object appears stretched infinitely thin. From far away, that future never arrives. But from the falling object's own perspective, something very different happens. Time continues to pass normally, at least initially. There is no sudden alarm, no moment where clocks stop. If the black hole is large enough, tidal forces near the horizon can be surprisingly gentle. Crossing the event horizon may feel uneventful. This dual perspective, time frozen from afar, yet flowing locally, is one of the deepest lessons black holes teach us. There is no single, universal timeline. Time depends on where you are and how you move. Inside the event horizon, space-time becomes so distorted that familiar distinctions begin to blur. Forward in time points inward, just as you cannot stop moving into the future. Inside a black hole, you cannot stop moving toward the center. The center, known as the singularity, is where current theories reach their limits. Density becomes infinite. Curvature becomes extreme. Our equations break down, not because reality stops, but because our understanding does. What happens to time there is still unknown. Some theories suggest time and space may swap roles. Others propose quantum effects that soften the singularity. But for now, the interior of a black hole remains a mystery. What matters for our journey is what black holes reveal about time itself. They show us that time is not just flexible, it can be stretched to its limits. Near a black hole, a minute for one observer can correspond to years for another. This makes black holes the ultimate time dilation machines. If you could orbit close enough without falling in, you could experience far less time than the rest of the universe. Return to distant space, and you would arrive in the far future. This is time travel into the future, taken to an extreme. Again, the universe allows it in principle. In practice, the challenges are immense. The energy required to approach such orbits is enormous. The radiation near black holes is lethal, and stable paths are rare. Yet the physics remains clear. Time does not resist being stretched. It responds predictably to gravity. Black holes also force us to confront a deeper question. If time can nearly stop, what does that say about the nature of the present? Is there a now at the event horizon? For the falling observer, yes. For the distant observer, no. The present becomes observer-dependent. This challenges the idea that the universe unfolds moment by moment in a single shared sequence. Instead, reality resembles a complex structure where different observers slice space-time in different ways. All slices are valid. None are privileged. This perspective is known as the block universe view. In this view, past, present, and future all exist within space-time. Time does not flow globally. It is experienced locally. Black holes make this idea hard to ignore. They show us that what feels like the passage of time may be how consciousness moves through space-time, not how space-time itself changes. And yet, even in this strange picture, cause and effect remain intact. Events influence other events. Information follows rules. Black holes do not allow messages to travel backward in time. They stretch time, but they do not reverse it. This is important because it hints at a boundary the universe seems unwilling to cross. It will bend time dramatically. It will slow it to a crawl, but it will not let effects precede causes. This boundary may be tied to entropy, to quantum mechanics, or to deeper principles not yet discovered. Black holes sit at the crossroads of these mysteries. They are laboratories where gravity, time, and quantum physics all intersect. And in that intersection, we glimpse how limited our everyday intuition really is. As you listen, these ideas may feel heavy, dense, but notice how quietly they arrive. Black holes are not loud monsters. They do not roar. They wait. They curve space-time gently at first, then more deeply, then beyond our ability to describe. Even the most extreme distortions happen according to calm rules. There is no rush, and here, far from any black hole, time flows steadily. Your body rests. Your breath rises and falls. The universe is vast enough to contain frozen moments and gentle ones. Both are part of the same structure. In the next chapter, we will step back from these extremes and ask a more direct question. If physics allows time to slow, stretch, and diverge between observers, does it allow us to truly travel through time, to choose our destination along the timeline? Or are these effects simply one-way doors into the future? For now, let the image of frozen moments soften into calm. Black holes remind us that time is not fragile. It can bend enormously without breaking. And within that flexibility, the universe remains patient, quiet, unfolding at its own pace. Chapter 6 is traveling to the future possible. After everything we've explored so far, the question almost answers itself. Is traveling to the future possible? Yes. Not in the way stories often imagine, with flashing lights or sudden leaps, but in a quieter, more profound way. The laws of physics already allow it. In fact, we are doing it right now. Every second that passes moves you into the future. But physics reveals something deeper. Not everyone moves into the future at the same rate. Time, as we've seen, is flexible, and because it is flexible, The future is not equally distant for all observers. The simplest form of future travel comes from motion. If you move fast enough, time slows for you, relative to those who remain still. This is not theoretical. It has been measured precisely. Astronauts aboard the International Space Station age very slightly more slowly than people on Earth. The difference is tiny, fractions of a second, but real. Their motion through space changes their motion through time. This means that if you could travel at a significant fraction of the speed of light, you could experience far less time than the rest of the universe. You would return to Earth, having aged only a few years, while decades or centuries had passed for everyone else. You would not have gone back in time. You would not have skipped moments. You would simply have followed a path through space-time, where less time elapsed. From the universe's perspective, nothing strange happened. From your perspective, you arrived in the future. This form of time travel does not violate causality. It does not allow paradoxes. It does not change history. It only changes how much time you personally experience. Gravity offers another path. As we explored earlier, time flows more slowly near massive objects. If you could spend time near intense gravity and then return to weaker gravity, you would again arrive in the future of others. This effect is real. But again, the practical challenges are enormous. The gravity required to produce dramatic effects exists near neutron stars and black holes. These environments are hostile. Radiation is intense. Tidal forces can be lethal, and the energy needed to reach and survive such places is far beyond our current abilities. So, while future travel is physically allowed, it is not easily accessible. Still, the existence of this possibility changes how we think about time. It tells us that the future is not a single destination. It depends on the path you take. Time is not a universal conveyor belt, carrying everyone forward together. It is a landscape where different paths have different lengths. This raises a subtle question. If future travel is possible, why doesn't it feel special? Why don't astronauts to feel like time travelers? Because the differences are small. Relativity becomes dramatic only near extremes. At human scales, time differences are gentle, comfortably gentle. This is part of why our intuition struggles with time. The universe behaves one way at ordinary scales, and very differently at extreme ones. Both behaviors are real. We simply live far from the edges. This also explains why science fiction often exaggerates to make time travel feel dramatic. Stories compress enormous physics into small spaces, but reality is patient. It stretches time slowly, quietly, always respecting causality. This brings us to an important boundary. Traveling to the future is allowed. Traveling to the past is far more problematic. Not because physics hates the idea, but because it threatens the structure of cause and effect. So far, every known mechanism that allows time to stretch still preserves order. Causes come before effects. In every observer's local experience, even near black holes, even at near light speeds, the universe seems to protect this rule. This protection may not be absolute. Physicists still explore possibilities, but it is deeply embedded in everything we observe. The future, in this sense, is open. The past is fixed. You can move forward at different rates, but you cannot revisit what has already happened. This asymmetry is deeply connected to entropy. Entropy increases. Memories form of the past, not the future. Records accumulate. The universe builds history, but does not erase it. Traveling to the future fits naturally within this structure. Traveling to the past would require entropy to decrease, records to unform, and effects to precede causes. So far, nature shows no willingness to allow this. This doesn't mean the past is locked by some cosmic rulebook. It means the universe's behavior makes backward travel extraordinarily constrained. The future, by contrast, is something we are always approaching. The only question is, how quickly? In a sense, future time travel is not about control. It is about perspective. You don't jump ahead. You take a longer route through space-time. Others take shorter ones. You all arrive at different futures. This idea reframes time travel from fantasy into geometry. It's not about breaking time. It's about navigating it. As you rest with this idea, notice how gentle it feels. There is no tearing of reality, no dramatic rupture, just different journeys through the same universe. This perspective also invites reflection. If time is experienced differently, depending on motion and gravity, then how much life you live is not just about duration, it is about experience. Two people can live the same number of years and feel entirely different amounts of time. Attention stretches moments. Routine compresses them. Physics and psychology quietly echo each other. Time is not only counted, it is felt, and the future we arrive in is shaped as much by awareness as by motion. This does not make science mystical, it makes it human. Einstein's equations do not tell us how to live, but they remind us that rushing is not fundamental, that there is no universal clock demanding speed. The universe allows variation, it allows slowness, it allows rest. As you listen now, you are traveling into the future at a very ordinary rate, one breath at a time, and that is enough. In the next chapter, we will turn to the hardest question of all. If the future is reachable, why does the past remain out of reach? What truly prevents us from going backward? And is that barrier absolute or merely practical? For now, let this thought carry you gently forward. Time is not an enemy. It is not a trap. It is a path, and you are already on it, moving forward exactly as the universe allows. Chapter 7. Why traveling to the past is so difficult. If moving into the future feels almost natural, then moving into the past feels deeply forbidden. Not just difficult, not just impractical, forbidden in a quieter, more fundamental way. Stories have imagined it endlessly. Machines that whirl and flash, doors that open onto yesterday, moments undone with a single step backward. But when physics examines the idea carefully, it grows very still, because traveling to the past does not merely stretch time, it rearranges meaning. At the heart of the problem is something so familiar that we rarely notice it: cause and effect. You light a candle, then the flame appears. You drop a glass, then it shatters. Every experience you've ever had follows this order. Cause comes first, effect comes second. This ordering is so deeply embedded that it feels inseparable from reality itself. Yet, traveling to the past would threaten this structure. If you could arrive before a cause occurred, you could prevent its effect, and that opens a quiet cascade of contradictions. These contradictions are often called paradoxes. The most famous is the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, he would never be born. But if you were never born, you could not travel back to prevent the meeting. The story loops endlessly, with no consistent outcome. Physics does not like inconsistency, not because it is unimaginative, but because the universe itself appears consistent. Every experiment ever performed has respected causal order. Effects follow causes. Information does not arrive before it is sent. This does not prove that backward time travel is impossible, but it places a heavy burden on any theory that allows it. Such a theory must explain how paradoxes are avoided. Several ideas have been proposed. Some suggest that traveling to the past creates a new branch of reality. You do not change your own past. You create another timeline. Others suggest that the universe simply prevents paradoxical actions. You can travel back, but you cannot change what already happened. Every attempt to alter the past somehow fails. These ideas are imaginative. They are logically interesting, but they come at a cost. They require assumptions about reality that go far beyond what we have observed. So far, there is no experimental evidence that the universe branches into timelines. No sign that reality rewrites itself to protect consistency. Physics prefers simpler explanations when possible, and the simplest explanation is that backward time travel is not allowed. This simplicity may arise from deeper principles. One of them is entropy. As we explored earlier, entropy tends to increase. This gives time its arrow. The past is more ordered, the future is more disordered. To travel backward in time would require entropy to decrease. Broken objects would reassemble. Heat would flow from cold to hot. Memories would erase themselves. At small scales, such reversals are not forbidden. Individual particles can move backward in time in certain mathematical descriptions, but at large scales, the scales of people, machines, planets, entropy overwhelmingly dominates. The probability of large-scale reversal is so small that it may as well be zero. This doesn't mean the laws of physics forbid backward motion. It means the universe's initial conditions and statistical behavior make it effectively impossible. Another barrier comes from relativity. Einstein's equations do allow solutions that resemble time loops, called closed time-like curves. In these solutions, space-time bends so strongly that a path can return to its own past. But these solutions require exotic conditions, negative energy densities, infinitely long rotating cylinders, perfectly arranged cosmic strings. So far, none of these conditions have been observed, and many physicists suspect they cannot exist in stable form. Even when mathematics allows something, nature does not always follow. There is also the question of quantum mechanics. At the quantum level, time behaves strangely. Particles exist in superpositions. Events are probabilistic. Some interpretations suggest that time itself may not be fundamental. It may emerge from deeper, timeless rules. If this is true, then traveling backward in time would be like trying to move backward through a story that already exists as a whole. The story is there. You are a part of it. You experience it sequentially, but the structure itself is not rewritten by your movement. This view aligns with the block universe idea. In this picture, past, present, and future all exist within space-time. You move through them, but you do not rearrange them. Backward travel would not let you change events. It would only let you observe them. But even this possibility remains speculative, and observation alone raises its own questions. Could you interact? Could information flow backward? Every interaction risks paradox. So the universe seems cautious. It allows flexibility, but not freedom without limits. Time can stretch. It can slow. It can diverge between observers, but it resists reversal. This resistance is not dramatic. There is no cosmic barrier with warning signs. There is simply no known path that allows backward travel without contradiction. As you rest with this idea, it may feel disappointing. Stories often promise second chances, undoing mistakes, fixing regrets. Physics does not offer that comfort, but it offers something else: consistency. The past is what it is. Because the universe preserves it, your memories exist. Because history remains intact, your identity is stable. Because events do not unravel. If time were easily reversible, meaning itself would become fragile. Nothing would stay done. The universe, it seems, chooses stability over revision. This does not mean the past traps us. It means the future remains open. You cannot go back and change what has been, but you can move forward in many different ways. And that freedom is real. As you listen now, you are not losing time. You are inhabiting it. The past has already shaped this moment. The future has not yet been written. And the present, this quiet, gentle present, is where experience lives. In the final chapters ahead, we will step back from mechanics and ask a broader question. What does all of this mean for how we understand time itself? Is time something we travel through, or something that emerges from change? And when we let go of fantasies about reversing it, what deeper understanding remains? For now, rest with the universe's quiet answer. Time moves forward, not because it must, but because the structure of reality makes it so. And within that forward motion, there is room for calm, for reflection, and for rest. Nothing is pulling you backward. Nothing is rushing you ahead. You are exactly where time allows you to be. Chapter 8. Time as a thought experiment. By now, time has softened. It is no longer a ticking clock on the wall, no longer a rigid line stretching from past to future. It has become something quieter, more spacious, something we can think with rather than fight against. At this point in the journey, physics begins to step gently aside, and philosophy steps quietly forward, not to replace science, but to listen to what science has revealed. Because once we accept that time can stretch, slow, and differ from one observer to another, a deeper question naturally arises. What is time, really? Is it a thing the universe contains, or is it something that emerges from change itself? One way physicists explore this question is through thought experiments. Not experiments with machines or laboratories, but with imagination carefully guided by logic. These thought experiments do not prove facts. They reveal assumptions. They show us what we are quietly taking for granted. When we talk about time, consider this simple idea. Imagine a universe with no change, no motion, no particles colliding, no stars forming or fading. no thoughts arising. Nothing happens. In such a universe, what would time mean? There would be no clocks to tick, but more importantly, there would be no events to mark. Without change, time would leave no trace. It would have no way to be measured and no way to be experienced. This leads to a subtle insight. Time may not be fundamental, change may be. Time could be a way of describing how change is ordered, not a river that flows, but a language we use. To talk about transformation, some modern theories of physics take this idea seriously. They suggest that time does not exist at the deepest level of reality. Instead, there are relationships, correlations, patterns. Time emerges when systems become complex enough to record change. In this view, time is not the stage on which the universe acts. It is the story we tell about how the universe changes. This may sound abstract, but its consequences are gentle. It means that time travel is not about moving along a pre-existing track. It is about rearranging relationships between events, and rearranging those relationships may not be possible without unraveling consistency itself. Another thought experiment asks us to imagine the universe as a completed structure. All events, past, present, and future, exist within space-time. Nothing is coming into existence. Nothing is disappearing. Everything simply is. In this picture, often called the block universe, the sensation of time flowing comes from consciousness moving along a path through this structure, like a spotlight sweeping across a landscape, illuminating one region at a time. The landscape does not move, the light does. This idea can feel unsettling. It seems to deny becoming, change, and novelty. But it does not. Change still exists within the structure. Events differ, states evolve. What disappears is the idea of a universal present, marching forward. Instead, each observer carries their own present. Time travel, in this view, would not mean leaving the block. It would mean moving to a different location within it. But how would you move if the structure already contains your entire path? This is where possibility quietly narrows. Physics allows us to move differently through space-time. It allows different rates of aging, different slices of now, but it does not show us how to jump off our path and re-enter it elsewhere. The block universe is permissive, but not playful. It allows variation, not rewriting. Other thought experiments focus on information. Information is deeply tied to time. Memories are information about the past. Records are physical traces. Photons carry messages. All known physical processes respect a simple rule. Information does not appear from nowhere. It moves forward, following causal chains. Backward time travel would allow information to arrive before it was created. A message without a sender, an effect without a cause. These situations are not just puzzling, they undermine the logic that lets science function at all. Because if information could circulate freely in time, prediction would collapse. Explanation would lose meaning. The universe, at least as we know it, does not behave this way. Thought experiments involving time machines often end in contradiction, not because we lack imagination, but because the universe seems to value coherence. This coherence may be more fundamental than time itself. Another quiet idea emerges from quantum physics. At very small scales, time behaves strangely. Particles do not follow single paths. They explore possibilities. Some equations work just as well, whether time flows forward or backward. Yet when systems grow large, classical time emerges. The arrow returns. This suggests that time may be an emergent property. Like temperature, temperature does not exist at the level of individual particles. It emerges from collective motion. Time may be similar. At the smallest scales, there may be no preferred direction. But when complexity increases, direction appears. If this is true, then time travel to the past would require manipulating reality at its deepest, most fundamental level, not moving a machine, but reshaping emergence itself. This is far beyond technology. It may be beyond meaning. So what remains? What do these thought experiments offer us? If not machines and destinations, they offer clarity. They show us that time travel is not forbidden by ignorance, but constrained by structure. The universe is flexible, but not arbitrary. It allows variation, but not contradiction. And within these limits, something remarkable happens. Time becomes less threatening. If the past cannot be changed, it becomes stable. If the future is not fixed, it becomes open. If the present is local, it becomes intimate. Time is no longer an enemy, stealing moments away. It is the framework within which moments gain meaning. As you rest now, you are not rushing through time. You are participating in change. Your breathing alters the state of your body. Your listening alters the state of your mind. These changes create time rather than consume it. This reframing is quiet but powerful. Time is not something you lose. It is something that happens because things happen. And as long as there is change, there is time. In the next chapter, we will gently draw these ideas together, not to reach a final answer, but to settle into a perspective, one that replaces urgency with understanding and fear with calm. For now, let time remain what it is tonight. Not a puzzle to solve, not a problem to fix, just the soft ordering of change, unfolding exactly as it needs to. You are not late. You are not early. You are simply here, where time allows experience to exist. Chapter 9. Living Inside Time. After exploring equations, extremes, and thought experiments, we return to something quieter: experience. Because no matter how flexible time may be, no matter how strange it becomes, near light speed or black holes, every question about time eventually arrives at the same place. Here, this moment. You do not observe time from the outside. You live inside it, and that fact changes everything. From a human perspective, time is not space-time diagrams or probability distributions. It is mornings and evenings, waiting and remembering, beginnings and endings. It is the feeling that something has passed and something else is coming. Physics can tell us how time behaves in the universe, but it cannot tell us how time feels. And yet, that feeling is real. It shapes decisions. It shapes identity. It shapes meaning. You are not just located in time. You are formed by it. Your memories are layered records of time's passage. Your sense of self is a continuity stitched together from countless past moments. Without memory, time would dissolve into fragments. Without anticipation, the future would lose its pull. So while physics reveals that time may not flow universally, experience insists that it flows for us. This is not a contradiction. It is a difference of perspective. Time behaves one way in equations. It behaves another way in consciousness, and both are valid. Consider this simple observation. You never experience the past directly. You experience memory. You never experience the future directly. You experience expectation. The present itself is not a single instant. It is a short window where perception integrates change. Neuroscience suggests this window lasts only a few seconds. Everything else is already a story. This means that your lived time is not a line. It is a constantly updating reconstruction. The mind does not sit on a timeline, watching moments pass. It actively builds a sense of continuity from fragments. This explains something deeply familiar: why time seems to speed up as we grow older. When experiences are novel, the brain records more detail. Time feels rich and expansive. When experiences repeat, the brain compresses them. Time feels faster. The clock has not changed. Your relationship to change has. This insight gently echoes physics. Just as motion and gravity alter time's rate in the universe, attention and novelty alter time's rate in the mind. Time is flexible at every scale. This flexibility invites a different question. If time is not something rigid, what does it mean to waste it? From a purely physical perspective, time does not belong to you. It is not a resource you spend. It is a dimension in which events occur. From a human perspective, however, time feels precious because experience is finite, not because time itself runs out, but because lives do. This distinction matters. It shifts the focus from fighting time to inhabiting it. You cannot stop time, but you can change how you move within it. This is not a motivational slogan. It is a structural truth. Physics allows different paths through space-time. Psychology allows different paths through experience. Both are forms of navigation. When people speak of wanting more time, they often mean something else. More presence, more meaning, more coherence. They want moments to feel less fragmented. This is not a failure of time. It is a signal about attention. In a sense, the most accessible form of time travel is not physical. It is experiential. When you become deeply present, time expands. When you become anxious, time tightens. When you reflect, the past comes alive. When you imagine, the future appears. None of this violates physics. It reveals another layer. Time is not just measured, it is lived. This layered nature of time can be unsettling at first. We often want a single answer. Is time real or not? Is it flowing or static? Is it fundamental or emergent? The universe seems comfortable with yes to all of these, depending on perspective. Time can be real and relational, static and experienced as flowing, fundamental in equations, and emergent in perception. These are not contradictions. They are complementary views of a complex structure. Living inside time means accepting this complexity without trying to flatten it. It means allowing mystery to remain where understanding ends. And perhaps this is one of time's quiet gifts. It prevents certainty from becoming rigid. It keeps curiosity alive. Even now, physicists do not fully understand time. They can measure it precisely. They can manipulate it mathematically. They can predict its behavior in many situations, but its ultimate nature remains open. Is time continuous or discrete? Does it emerge from quantum entanglement? Is it tied to consciousness in ways we have not yet recognized? These questions are not failures. They are invitations. They remind us that time is not something we have finished thinking about, and perhaps never will. This openness mirrors human life. You do not know exactly who you will be in the future. You do not fully understand who you were in the past. You exist in an unfolding process, just like the universe. As you listen now, you are participating in time, in the simplest possible way. Breath follows breath. Thought follows thought. No effort is required. Time does not demand attention. It only responds to it. If you resist it, it feels harsh. If you align with it, it feels gentle. This alignment does not mean resignation. It means rhythm. Sleeping when it is time to sleep. Resting when it is time to rest. Acting when it is time to act. These are not productivity rules. They are ways of moving, with time rather than against it. The universe itself moves this way. Stars form slowly. Galaxies evolve patiently. Entropy increases without hurry. Nothing rushes. Nothing lingers unnecessarily. Everything unfolds. In the final chapter, we will bring this journey to a close, not with a conclusion, but with a settling, a way of holding time that is lighter, less anxious, and more spacious. For now, let this moment remain simple. You are not behind. You are not ahead. You are where experience is possible, and that is the only place time ever truly exists. Chapter 10. Returning home. Slowing down. After traveling across ideas of motion, gravity, black holes, paradoxes, and thought experiments, the journey does not end with an answer. It ends with a return to the place we never really left. Here, time, when viewed from far enough away, can feel vast and abstract. Billions of years, cosmic epochs, futures that stretch beyond imagination. But when we come back to ourselves, time becomes intimate again. It becomes breath. It becomes heartbeat. It becomes the quiet rhythm of being alive. This chapter is not about discovering something new. It is about allowing what we have already seen to settle. We began with a simple question. Is time travel possible in our universe? Science answered carefully. Traveling into the future, yes, through motion and gravity. Traveling into the past, no clear path. Not without breaking the structure that keeps reality consistent. But beneath these answers, something more subtle emerged. Time is not an enemy. It is not a force chasing us forward. It is a structure we move within. And like any structure, how it feels depends on how we inhabit it. When we rush, time feels sharp. When we compare, time feels scarce. When we fear loss, time feels like it is running out. But when we rest, time softens. It becomes wide enough to hold experience without pressure. This is not philosophy alone. It reflects what physics has been showing us all along. There is no universal clock demanding urgency. There is no cosmic deadline hidden in space-time. There are only local clocks, each moving according to their own conditions. Your body has one. Your mind has another. Neither is wrong. They simply reflect different layers of time. The universe does not rush galaxies into place. It allows them to form slowly. It does not hurry stars through their lives. It lets them burn for billions of years. It does not panic when entropy increases. It accepts change as part of structure. In this sense, The universe is deeply patient, and you, as a part of the universe, are allowed to be patient too. Returning home in time means releasing the fantasy that we must outrun it. Time cannot be escaped, but it does not need to be conquered. It needs to be accompanied. When Einstein described time as flexible, he did not remove its meaning. He expanded it. He showed that time is not a rigid container, but a relationship between motion and rest, between mass and space, between observer and experience. This means that how time feels is not fixed. You cannot change the universe's laws, but you can change how you align with them. Slowing down is not resisting time. It is matching your pace to the scale you actually live at. Your life does not unfold at the speed of light. It unfolds at the speed of breath. Trying to live faster than that creates friction, not because time punishes you, but because your rhythms become misaligned. This misalignment often shows up as anxiety about the future or regret about the past. Both pull attention away from where experience happens, the present. Physics tells us there is no universal present, but experience insists there is always a local one. This moment, it does not need justification. It does not need to lead anywhere. It simply is. And in it, time is not missing. It is complete. There is a quiet comfort in realizing that time travel fantasies often reflect a deeper wish to redo, to control, to secure outcomes. But the universe offers something else. Not control, but consistency. Not reversals, but continuity. This continuity allows learning. Mistakes remain, but so do their lessons. Memories stay intact, but they soften. The future remains uncertain, but that uncertainty carries possibility. If time could be freely reversed, meaning would dissolve. Nothing would settle. Nothing would stay done. The universe seems to understand this. It protects the arrow of time, not as a restriction, but as a foundation. A foundation for stories, for identity, for growth. Returning home, then, is not about accepting limitation. It is about recognizing structure. And within structure, there is freedom. Freedom to choose attention. Freedom to choose pace. Freedom to choose how deeply a moment is inhabited. As you listen now, time is not slipping away. It is unfolding. There is no better use of time than being present for it. This does not mean every moment must be profound. It means every moment is sufficient. Even this one, especially this one. The universe does not measure your worth in seconds. It does not tally productivity. It does not evaluate speed. It simply allows experience to occur. And when experience ends, time does not mourn. It continues, quietly, without judgment. This is not coldness. It is stability. It means the universe will not collapse. If you rest, it will not fall apart. If you slow down, everything has time, because time is not scarce. Experience is, and that makes presence valuable. As this chapter comes to a close, there is nothing to resolve, no paradox to fix, no destination to reach, only a gentle understanding. Time is not something you must escape. It is something you are already inside. You do not need to travel through time to arrive anywhere meaningful. You only need to notice where you already are. The journey began with a question. It ends with a quiet answer. Time is possible. Time travel, in small ways, is already happening. But the deepest movement through time is not forward or backward. It is inward. into awareness, into stillness, into rest. And from there, time continues, unhurried, patient, carrying you forward, exactly as gently as it always has. Drifting beyond the question, and now, the question that began this journey, can slowly fade. Not because it was answered completely, but because it no longer needs to be held. Is time travel possible? In the vast language of physics, we learned that time can stretch, slow, and gently diverge between paths. We saw that the future is reachable, in quiet, lawful ways, and that the past remains stable, held in place by the deep structure of the universe. But beyond equations and extremes, another understanding emerged. Time is not something standing outside of you. It is something you live inside. It is shaped by motion, by gravity, by memory, and by attention. And here, in this moment of stillness, time is doing exactly what it always does. It is allowing experience to unfold. There is nothing left to solve, nothing left to chase. The universe does not require urgency. It does not demand speed. It simply continues. Stars will burn quietly. Galaxies will drift patiently. Moments will arrive and gently pass. And you, right now, are exactly where you need to be, within that unfolding. If your thoughts begin to wander, let them wander. If they begin to soften, let them soften. Time will keep moving, whether you notice it or not, so you can rest. Let the question dissolve into quiet curiosity. Let curiosity dissolve into calm. Let calm dissolve into sleep. The universe will still be here when you wake, and time, unshaken and patient, will carry on, softly, endlessly, without asking anything of you at all. Good night.